So for questions about the domain, the thing to remember is that you want to put a real number in and you want to get a real number out. And if something is undefined, it is definitely not going to be real. So an undefined is a real issue. So we talked about this in chapter 2 about how you want to avoid denominators and square roots because those are not going to be real. So when we're talking about a rational function, our big concern is going to be what causes an undefined. And that undefined is not a real input, so we got to make sure we avoid getting out an undefined. Now, an undefined, again, is caused by where the denominator is equal to 0. So for our domain, we want to ensure that our denominator is not equal to 0, because if it's equal to 0, then we're going to get an undefined, and it's going to be a real issue because we're not going to get a real number out. So on these questions for find the domain of the rational function, what you're really after is where is the denominator equal to 0, because you want to avoid those numbers at all cost. So what we do for finding the domain, I always think about d in domain, d in denominator. We set the denominator equal to 0. Now, a lot of this question is really trying to figure out how to solve this equation. And the first thing that should stand out to you in this particular case is that you have parentheses, parentheses. And whenever you are in that form, that means that you are already factored. And if you're already factored, there is no need to go and sit there and distribute everything out. Because you are already factored, we just need to set each of those factors equal to 0 and solve. So it's as simple as we're already factored, that step is done for us, and so we're going to set each of the factors equal. So when we do that, we get -5 and -4. Now, if you look at the answer choices, it's pretty abundantly clear from there that you do not want these numbers, but just keep in mind you solve it as if it's an equal to, but then we do not want those numbers, so we would write that our domain is going to be all x values such that x is not equal to -5 and -4. And that would be our final answer for the domain in set builder notation. Now, if you contrast that to question number 75, again, same idea, we want to set the denominator equal to 0. But here in number 75, we do not have this form of parentheses, parentheses. So that means we first have to factor it. Now, we're not just going to move the 64 over immediately. We notice that we have this x squared, so it is a quadratic equation. And as a quadratic equation, you have options in life. You can go through factoring, you can go through the square root method if you want to, or you could go through the quadratic formula. Probably the easiest way to do this is just going to be to factor it as a difference of two squares or use the square root method. So here I'll factor, again, the square root of 64 is going to give us 8. So we're going to have x plus 8 and x minus 8, and we'll set those equal to 0. So we factor as a difference of two squares, set the factors equal to 0, and then we are home free. We want to make sure that we do not have -8 and we do not have 8, because those two numbers will cause a 0 in the denominator. So again, we do not want, do not want, do not want, and so we would say that our domain D is going to be given by x such that x is not equal to -8 and +8. So the key thing to remember from all of this is we need to set our denominator equal to 0. Once we set our denominator equal to 0, if it's already factored, we're almost there. We just have to set the factors equal to 0. If it's not already factored, as in number 75, then we need to factor first and then set each of the factors equal to 0. So factor and then set them equal to 0.